So how can keys help us solve this problem here? To understand this, it's important to understand that Flutter determines whether an element can be reused or not simply by taking a look at the type of that element. For example, to-do-item. And if that type is in line with the type it finds in the widget tree in that position where the element is, it's happy. And it keeps that element and just makes sure to update the reference to the widget it found in the same place in the widget tree. That's all. But it just takes a look at the element type and the widget type. And that's why the state doesn't move along, because of course the types here didn't change. We're still dealing with to-do items. But this behavior changes if we introduce keys. If we add keys to widgets, those keys are also added to the elements. And now if your widgets move around, the keys move with them, and if Flutter finds a key on an element, it does not just take a look at the element and widget types, but also at their keys. And therefore here it would then see that the keys don't match, and it would then also update the key on the element and move those states. So it would move the elements, you could say. And therefore then, with the usage of keys, which are simply an additional identification criteria, allowing Flutter to match elements to widgets, Flutter is able to make sure that every widget has exactly the element with exactly the state it needs. So therefore here, in this example, the fix is to go to key start and add a key to our checkable to-do items. And that's also why it's recommended to accept a key in the constructor function on all your own widget classes, because that makes it very easy to set a key if you ever need to do that. Now the key is then forwarded to the parent class so that Flutter can do its thing with it, but that is why you should always accept this key parameter so that you can always set it if you need to. Like here, where I actually need to set a key on the checkable to-do item, which also accepts keys, of course. And we can set that key by adding that key parameter, which we are accepting in the constructor function of this widget. And the only remaining question now is, which kind of value should we set as a value for this parameter? Well, and here you got two main keys which you should typically use. The first one is a so-called value key created with Flutter's value key class. Value key wants a value, any kind of value. It's a dynamic type, so you can pass a number, a text, or anything like this, and this will then internally be used as an identification criteria. So therefore here we could, for example, use the to-do text, because that should be unique for every to-do. If our to-dos had IDs, we might want to use those IDs instead, because that would be an even better value. But here it's the to-do text, and if we add such a value key here, we'll see that now in this app, indeed the state does move together with the widget. So now this app is working the way it should. Now, as an alternative to this value key, we could also use an object key, and then we could use the entire to-do object as a value. That is also something you could do, though I personally prefer the value key simply because behind the scenes it's also a bit more lightweight, because it only needs to manage a single value instead of an entire object. But both keys work fine. The only important thing is that those values must be unique and must be directly connected to your data. So don't use any random numbers that change all the time or anything like that, but instead use key values that are directly connected to your data and that are unique.